mentoring. Thank you. Okay. Please notice the announcements that Dr. Leek has put up on the screen. And there's our kind of some background of questions people tend to ask. So that, and you have my name and email, but it's also when I send each of you the instructions, you have my name and email. When the talk is over, Sarita Carter-Schmidt is recording it, and we'll get a copy of the slides, but I always give the speaker a chance to check the slides and make changes as they go, if they see any they want to make. Once they're posted, everyone who signed up, I will then send you links to where the recording is and where the slides are as we get the links made. Okay, I also want to thank Ms. Sarita Carter-Schmidt for overseeing the recording of the talk and all the other mechanics related to the talk. During the talk, please send any questions or comments for Dr. Leek to use the chat feature, which what she's going to do is look at everything, and she's going to prepare a list of questions for Dr. Leek to kind of streamline things. But we're not going to censor the questions. She's just going to collect them. And if there's anything else that happens, email me. I will be monitoring my email during the talk, so there should be no problems that way. Now I'm going to introduce Dr. Leek. Dr. Leek, or Dr. Jeffrey Leek, I should say, Jeff Leek, received his bachelor's degree in mathematics from Utah State University and his PhD in biostatistics from the University of Washington. He's a professor of biostatistics and oncology at the Johns Hopkins Bloomberg School of Public Health and is the co-director of the Johns Hopkins Data Science Lab. His group develops statistical methods, software, data resources, and data analyses that help people make sense of massive scale genomic and biomedical data. As the co-director of the Johns Hopkins Data Science Lab, he has helped to develop massive online open programs that have enrolled more than 8 million individuals and partnered with community-based nonprofits to use data science education as an economic and public health innovation. Okay, Jeff, your turn.
Great, thank you very much. And thank you, Carol, for the invitation. Thank you very much to the Washington Statistical Society. I really appreciate you all coming out to listen to a talk in the afternoon like this. Just wanted to confirm, I can't actually see you. So can someone say that you can hear me, just so I know I'm not talking to the void?
Yes, we can hear you.
Okay, great.
Okay,
great.
So I'm going to mute myself now too.
Great. So here, let me go to the next slide. So I'm going to be talking about what we call a mutually intensive data science learning as an economic and public health intervention. So this is a work by a large number of people at Johns Hopkins, including many people at the Johns Hopkins Data Science Lab. And I'll tell you a little bit more about this multi-year project that we've been working on for the last couple of years. You may hear in the background, my kids' school has just ended, so there's going to be probably some shouting and stuff with my kids, so hopefully that won't be too distracting. I guess we're all dealing with new circumstances for giving these sorts of talks. So if I do talk pretty quickly and I use a lot of slides, if you want to keep up with everything I'm talking about, you can go to jtleek.com/talks, and all of my talk slides, including the talk from today, will be posted there, so you can follow the slides there. So the premise of this talk, and I think is a premise that I think a lot of us believe in, is that talent is equally distributed. So these are a number of young people who we've worked with over the last few years. This is one of our cohorts of our training program. This is Andre, Anthony, Yarmaine, and Antonio. And what we've been identified is that there's these really talented individuals that are living in the communities around where Johns Hopkins Bloomberg School of Public Health is, but who don't always have access to the educational opportunities that those that go to Johns Hopkins do. And so while talent is equally distributed, opportunity, as we all know very well, is not equally distributed. And so the purpose of this project has been to try to distribute the opportunity a little bit more so that people with talent can take advantage of that opportunity and really improve their lives and start new careers. And so just to give a little context, so this is the neighborhood where I normally work. Right now I work from home, but when I go into a job, this is the neighborhood where I work. This is data from the Economic Opportunity Atlas. It was put together by some professors at Harvard. They looked at data from the Census Bureau and data from the IRS, and they looked at what's the median income for a person that is born in this neighborhood by the time they reach their mid-30s. And you can see that the median family income in this neighborhood is around $18,000. So it's considerably less than what you would expect, given that there's a massive multi-billion-dollar institution right down the street at Johns Hopkins. So this whole project has felt like what we're trying to do is address a problem like that's as big and pervasive as that. And so it always feels a little bit like we're doing this. We're like you'll see there's been a lot of sort of mistakes along the way and things that we've tried to do. And it's all felt a little bit like we're trying to fix things as the train is going down the track. And so hopefully we've learned a few things, and hopefully as we go, you'll be able to learn what are the things we did maybe pretty well, and what are the things that you can learn and not repeat that we did poorly. So if there's anything good that you hear about during this talk, it's almost certainly due to one of the people on the screen here. These are a large group of people that help contribute to this project in a variety of different ways, from students and postdocs at our Hopkins location to collaborators at in the Hopkins administration, to collaborators, our nonprofit partners, HEBCAC and YO and Heart Smiles, to some collaborators at this company that we founded called Problem Forward that I'll tell you a little bit more about later. So, if anything good you hear about, it's almost certainly due to these folks here. They're the real MVPs of this talk. If it's anything you kind of disagree with, it's almost certainly my fault. So I thought I'd start by setting a little bit of context. So income inequality, as we all know very well, is a public health problem. And so I'm going to describe a couple of trends that I think were really motivational for us when we set out to do this work a few years ago. So this is a plot, again, from this Opportunity Atlas. This is data. It's not simulation or anything like that. It's real data. And it shows on the x-axis the income percentile for your how much money you make. So people who don't make very much money at all are on the left side of the axis at 0, and people who make a lot of money are over at the 100th percentile. And on the y-axis is the life expectancy. And the purple dots are for females and the yellow dots are for males. So women tend to live a little bit longer than men. But one thing that's really incredible is if you look at the sort of 10th percentile of income and the 90th percentile or 80th percentile of income, then there's this huge gap in life expectancy. There's quite a big gap in the number of years that you live based on how much money that you make. Similarly, if you look at almost every other measure of public health, it's a similar sort of issue. So if you look at your parents' income percentile between 0 and 100th percentile, so 0 being your parents didn't have very much money at all, and 100 meaning your parents are very rich. If you plot the incarceration rate, the fraction of individuals that are incarcerated in their mid-30s, there's a dramatic difference in the incarceration rate between people who have a lot of money and people who don't have very many resources. At the same time that there are these major correlations between how much money you have and all sorts of things, your health, your freedom, etc., there's also increasingly less and less income mobility in the United States. So this is a plot of income mobility in the United States. It's the probability here that you will, that if you are born to parents who don't have very much money, that you will end up in the top income, or how much income you will make if you're born to parents with very low income. And so red means that you will likely have very low income if your parents were not very well off. And blue means that you'll be sort of a little bit more in what we would call middle class incomes. And so you can see that there's parts of the US, and Maryland is one of those parts, where there hasn't been the sort of economic mobility that one would hope, where you can go from parents who don't have very much money to you having more money when you grow up. And so again, this is where we got this plot. If you zoom into the sort of Baltimore area, you can see that the median family income in that neighborhood is very low, even though there's a lot of good businesses around there where people could have opportunities for careers. It's not just a problem in sort of urban areas or areas that are in big cities. It's also a problem. This is in the small little town I grew up in Idaho, Pocatello, Idaho. Just north of there, there's a Native American reservation, and there's a significant problem, again, of economic mobility. This isn't because there aren't talented people there. It's, again, entirely because the lack of opportunities for individuals from these communities compared to the opportunities, even in communities not very far away. So what does this have to do with education? Well, it turns out that education is still the best intervention we've ever invented for increasing economic mobility. So I'm going to talk a little bit about something called the mobility rate. So this is a measure that you can take of a particular college or school. And the mobility rate is access multiplied by the top quintile success rate. So I'm going to break that down a little bit. Access means the fraction of students that get into that college or school whose parents come from the bottom quintile of income. So how easy is it for you? What's the probability you can get into that school if your parents come from a low income quintile? Multiplied by the chance that at age 34, if you go to that college, you will end up in the top quintile of income. So it's sort of the probability of getting in multiplied by, conditional on you getting in, the probability that you will end up in the top quintile of income. So something like how good that school is at moving people up from the lowest quintile of income to the top quintile of income. So this is a plot where on the x-axis we show access, so how easy it is for you to get into the college if your parents don't have very much money, and on the y-axis, the success rate, how likely it is that you will end up in the top quintile of income if you go to that college. And each dot is a college. So you can highlight a couple of points. For example, this is Johns Hopkins University. So it's actually quite hard to get into Johns Hopkins if you don't have, if your parents are low income. It's quite rare for you to get in, not hard necessarily, but definitely rarer than some of the other colleges. But if you get into that college, you will have a relatively high chance of ending up in the top quintile of income. So there's this kind of L-shaped pattern you might notice where the colleges that are highly selective for people that come from the higher quintiles of income also have higher success rates. And over to the right, there's sort of colleges that have higher access rates but tend to have slightly lower success rates at moving people into the top quintile of income. But the interesting thing is for each individual college or each individual tier of colleges, it's, education, kind of irregardless of what your parents' education was, or sorry, income was, you have a very good chance of moving up to the sort of level of income for that college. So for example, if you look at the purple line at the top of this graph here, that's if you go to an Ivy League plus school, that's sort of one of the fancy Ivy League schools. And the x-axis is your parents' income quintile. So 1 being your parents didn't make very much money at all, 5 being your parents were very rich. And then the y-axis is the fraction of kids that go to that university from that parent's income quintile that end up in the top quintile of income, so relatively well off. And you can see it's relatively flat. There is a little bit of an increase left or right, but overall, once you get into the college, the probability of ending up with a relatively good income is quite high. And so this suggests that education, an opportunity once given to people, regardless of their background income, gives them the chance to move up and have a better economic opportunities. So this is a table of the colleges that have the absolute best success rate at moving people from, mobility rate for moving people from the lowest quintile of income to the highest quintile of income. And so the best in the country is currently Cal State University, LA. There's a variety of universities here. You'll notice they're largely large, public, high access universities. And some of them are sort of technical colleges. So it's a combination of a relatively good access rate and a relatively good success rate gives you a mobility rate of up to 10%. So up to 10% is a sort of best case mobility rate. So our question is, how do we address this? How does this relate to us? How does this relate to what we've been doing at Hopkins? So one interesting thing about those college success rates is they're for every single major, but we have been working on developing education in a very highly technical area where there tends to be a lot of jobs. Obviously, the pandemic has sort of changed that a little bit, but it's still a very high demand area in a technical qualification. And we've been doing sort of scalable data science education for a while at Hopkins. So this was a paper that was written by my former postdoc, Abuzar Hadavan, who's now a faculty member at Minerva. And he looked at whether our MOOC programs could improve student unemployment or employment prospects. So he took a survey sample of all the participants, a cross-sectional survey of everybody who enrolled in one of our Coursera courses. And he compared that sort of sample to the data that we collect from Coursera. And it turns out that it's relatively the same sort of distribution of characteristics. So this is a sample of people that took one of our classes. We have this large data science program that enrolls up to, millions of people. And so we were looking at what happens with their employment. And so if you look, here's a plot of yellow is people who took that survey who didn't pass any of our courses. There's a 10 course sequence. So blue is sort of you passed a few of the courses, between 1 and 5, so up to about half of the courses in the sequence. And green is more than 5 courses completed, so like more than half of the sequence. And on the y-axis, it's the amount of money that you made after you were enrolled in the sequence. And so you can see that as you complete more courses, on average, you have a slightly higher income. In fact, you can look at how much our program costs. So it's now costs right around $1,000 to complete the data science specialization, which is this big Coursera program online. And so we can plot that on a log scale on the x-axis, how much the program costs, versus how much you make, what's your increase in earnings on the y-axis. And so you can see with the DSS program, you get a bump in earnings that's almost equivalent to sort of a college degree from a very low cost program. And so that was quite inspiring. Obviously, we have some advantages over a full college experience in the sense that we're very focused on a highly technical area that has a lot of demand. So of course, you expect to see a little bit more of a bump than you would expect when averaging over an entire college. So the problem is, though, that getting access to this education has not always been sort of easy for everybody. So the challenge that people have noticed, not just us, but everybody when they analyze data from these programs, is that for the most part, people who take these programs already are either college educated and above and frequently have advanced degrees. So the real lesson, take-home lesson we learned, and everyone else learned when creating these massive online open programs, is that if you build it, they won't necessarily come. So the MOOCs are largely reaching privileged learners, these surveys have found. And so if you look at, this is data from our program, but if you looked at data from almost anybody else's massive online open course program or boot camp program, you'll see the same sort of pattern. Most of the students who take the program have a bachelor's degree, a master's degree, a professional degree, or a doctoral degree. And there are relatively few that come in that have less than high school education, associate degree, or some college, but no degree. And so our question, or our hypothesis, the thing that we really wanted to try to do with this program is, can we build something for folks that don't necessarily already have a fancy advanced degree, but want to get into this really hot and well-regarded field of data science? And so we sort of set out to see if we could do that. And so our goal really is this sort of really simple equation. We want to maximize the mobility rate. So we want to make the mobility rate as high as possible for our program. But we're a relatively small program at, Hopkins is a big place, but we're a very small group within Hopkins. And so we also wanted to make sure that we were not making the program too expensive or too time consuming so that we could actually deliver it to as many people as possible. So the question really is if we work with nonprofit partners in our neighborhood who identify talented young people who might be interested in data science, how do we take them from, the nonprofits we work with, people typically have jobs that include security guard, food services, things like that. How do we take a person who has a job like that and get them to a data science role at a company in the tech industry? And so we really thought about this from first principles, and we thought about what the barriers for that person might be. And so first of all, they would have to know what data science is. They'd have to know it's a field and that you could do well in it. You'd have to have enough income security that you could sort of support yourself while you were learning to be a data scientist. You need access to an expensive computer. It's been said a data scientist is a statistician working on a MacBook Pro, and that could set you back about $3,000. So obviously that's a pretty expensive investment. You need access to the right programs, access to instructors. Then once you do all that, you still have to have access to the right jobs and access to connections. And if you kind of get through all of that, then you can kind of move from one side to the other and move into this new kind of job. And so the rest of this project is really just us thinking about how do we remove each of these barriers one by one. So starting with the expensive computer, we have for a while been experimenting with using Chromebooks to do all of our data science. And so that's really now become very valuable in the light of the pandemic and everybody working on Chromebooks. So this is a blog post I wrote, a few years ago on doing data science on a Chromebook. I've actually exclusively used a Chromebook for the last 3 or 4 years, including this presentation here today is on a Chromebook. And so we figured out that you can do most of the things that a data scientist needs to do on a Chromebook. So you can create presentations like the one I'm presenting here today with Google Slides. You can create spreadsheets and edit them with Google Sheets. That's kind of an Excel replacement. And then the real kind of workhorse, or the real sort of star of the show here, is RStudio Cloud, which is a piece of software that was originally completely free. Now it's free for a little while, and you have to pay a little bit of money once you sort of have been using it for a while. But it's a version of R that you can access entirely through the cloud and entirely through a web browser. And so the idea here is that you can do the entire program that we're going to develop on any computer with a web browser and an internet connection. So we're talking about Chromebooks, but the reason why we're talking about Chromebooks is it represents the sort of lowest common denominator. It's just a web browser with an internet connection. And so you could take our programs that we've designed on a Chromebook, but you could also take them in a public library, anywhere with a web browser and an internet connection. So then the next big question was, what about knowing about data science? Remember that I sort of showed you a minute ago, I talked about how most of the people that are taking these massive online open courses are people that already have bachelor's degrees, master's degrees, and higher. So we have to actually like reach out and identify, interested parties who maybe don't know about data science, and we can sort of present the opportunity to them. And so here we actually reached out to a nonprofit partner in East Baltimore. So there was a nonprofit that was actually run by a friend of mine. At the time, he was the president of that nonprofit. And it was the Historic East Baltimore Community Action Coalition. They have something called a Youth Opportunity Program, where they help young people who have not finished their high school diploma to come back and complete their high school diploma. They would identify talented individuals for us, and they would help support and provide wraparound services to the individuals that would go through our training program. They've been an incredible partner, and we've learned so much from them, and I'll talk a lot more about their contributions here in a minute. So then they need access to appropriate programs if they wanted to sort of move into data science. And even the programs that we have developed are sort of relatively expensive. They make quite a bit of assumptions about what you need to know. But one thing that's really cool about the R programming language in particular is how over the last few years, there have been a number of packages that have been developed that allow you to do what I would call essentially magic with just a few lines of code. And so here I'm showing you an R Markdown document. The R Markdown document, the code on the left is all the code it takes to produce the website on the right. So it's only like 5 or 6 lines of code, and you can have a cool interactive website. The Flex dashboard package is really another kind of incredible miracle worker. And so on the left, you see about 25 lines of code. That code produces the interactive dashboard on the right with all the sort of movable sliders and the interactive chart and everything. It's really kind of an incredible amount of sort of interactivity for just a small amount of code. And then dbplyr is a package that allows you to connect to big databases and manage huge data sets even with a small amount of code. So here I'm analyzing over 3 million lines of code with just a couple of lines of R code. And so what we thought is we can use this magic, we can kind of develop a program that really takes somebody from never having heard of data science before to being really functional, really magical by taking advantage of this infrastructure, taking advantage of these packages that have just been developed. So we settled on creating a new program called Cloud-Based Data Science. This is a new set of MOOCs, not the one that millions of people have taken, but a new one we developed specifically for this program. And the idea here is we wanted to start at the very basics. We start at how do you use your computer, how to use Google in the cloud, all the way from sort of the basics of how to do things with a computer to how do you organize data sets and do version control, to like the real heart of data analysis, and then some of the soft skills, things like written and oral communication, getting a job in data science, really trying to cover the entire trajectory for someone so that they could go from never having heard of data science before to having enough skill to be an entry-level data scientist. And so our original plan for doing this, we sort of planned on starting, we originally had the idea and started doing content development in February 2018. In April 2018, we had our first meeting with our nonprofit partner, Yo. And once we kind of had a conversation with them, and they got incredibly excited, and they were like, can we start next month? And of course, we had to develop an entire program, and we had just started in February, so that was, of course, a very aggressive timeline. We said, can you give us like a month and a half? So we kind of pushed back to May 21st. To start this program, to start the initial cohort with just 2 people that we sort of had identified through this nonprofit partner who could be very talented and could help sort of show off how the program could work. So remember, we had to build 12 courses, and we had to build them in about a month and a half. And as you can imagine, if you've had to ever build a course in your life, that is not very much time to build technical content. And so this is what I felt like when we realized that we had just like a couple of months to build all of these courses. But very fortunately for me, I had a couple of incredible people working with me. Really a couple of people to highlight here on this slide. These are all people that contributed to content over the course of that really sort of rushed time of releasing these courses. But the real heroes of the story here are Shannon Ellis and Abuzar Hadavand, who were both postdocs of mine and now in faculty positions, as well as John Michelli and Sean Cross, who helped build software that allowed us to really rapidly create this content and update it and keep it up to date. Then, Ashley Johnson has come in and really sort of taken over program management from them. And so this is like an incredibly diverse, incredibly interesting team of people that like pulled together to make this possible. So we sort of addressed a couple of those pieces. We addressed knowing how to do data science, having access to an appropriate program, but we still have this problem of we need to get people computers, we need them to have access to instruction, and we really need them to have income security. So a lot of the folks that we work with don't necessarily have the ability to just stop everything that they're doing and take a 20-hour or 30-hour a week program for free. And so we started thinking through how do we actually address these problems together. And so what we came up with is something we call Cloud-Based Data Science Plus, or CBDS Plus. So this program layers on top of our massive online open core sequence. We basically provide people with a Chromebook laptop, a free low-cost laptop. We provide them online support through a Slack channel. So at the time we were running this program, my postdocs stayed up really late, and I get up really early because I have small kids. And so they basically got 24-hour concierge support on this Slack channel to answer their R questions. We had in-person office hours 3 hours a week so that they could go over projects and learn from what they were doing. We would pay them as they completed courses. So, it took about 20 hours. We estimate about 20 to 30 hours a week for them working. And so we would pay them as they completed the courses so that they could afford to take the courses kind of as a part-time job. And then we would provide them job search assistance to try to get them employment opportunities at the end of this. And so the whole idea here is, can we kind of create this sort of economic opportunity ladder for people who are already talented but just haven't had this kind of opportunity in the past? And so that was sort of our plan. So again, we kind of went back to Yo and we worked with them to create the CBDS Plus program. And the real heroes here is Yo. Teaching young people how to do stuff with computers is, really important, and it's challenging, but a lot of the real challenges came up with all of the different things that like prevent people in their lives from being able to take advantage of these sorts of things, whether it's sort of a housing insecurity problem, a financial insecurity problem, or sort of a social problem. And so Yo is really the hero of that story in the sense that they really provided the wraparound services and support so that the youth that came through our program could be successful. And so our sort of ideal candidate for this program, the way we sort of structured it, is we wanted a Baltimore City resident between the ages of 18 and 24. They had to be a registered member at the time of this youth opportunity in Baltimore. They had to possess a high school diploma or GED with an interest in computers, programming, or coding. They had to have this ability to complete. We kind of created the program into a 14-week structured program, so they needed to be able to spend the time to complete that program. They needed to be interested in full-time employment upon completion, able to pass a background check, strong communication skills, and then sort of self-motivated, because this is a hard thing to do and it's a real accomplishment to complete this course sequence. So just to kind of take a step back and talk about what all the different parts are, because I know I've kind of outlined different parts of this project. So CBDS is a cloud-based data science, is a massive online open course. It's free online. If you go to clouddatascience.org, you can take those classes for free yourself right now. They're open to anybody. CBDS Plus is this on-top layering service that we did to sort of help people from Yo complete the program. They got access to in-person tutoring, cash payments to complete, Slack, free laptops, and job search assistance. And then Yo provided wraparound services, which is one line here, but should be listed as about 50 lines, which is like everything that could possibly come up in your life. They were really supportive of that kind of component of the project. So we started with a pilot project. And so this, we originally were going to try to launch this to like thousands of people all at once. And then I had a good friend come and visit and give a talk at Johns Hopkins. And he said, slow down. Why don't you just try to do 2 people and see if it works before you try doing it for everybody? And so we had 2 sort of really intrepid people who decided to do the pilot with us. They started in May of 2018 to sort of take on this project. And we needed to know how long it would take them to complete. Remember, we had just invented most of the course content. We had no idea how long this was going to take. So we really had no idea how long to tell them that it could take. And so we just guessed. I mean, we made up a number like out of thin air. We said, let's say this is going to take about 3 months. So this was sort of our projected timeline, again, made out of total thin air. Ultimately, this is what ended up happening. They ended up taking a little bit longer. There were 2 reasons for that. The primary reason being that we were slow. We actually were rolling out content just ahead of them. We would like roll out a class and then they would take the class, and we'd roll out a class and take a class. Sometimes we'd be a little bit late. So, and then the other thing was it just like we didn't know how long it would take. And so we had to kind of readjust how long the program would take. We've since settled on about 14 weeks for the program to be completed. But we kind of started with his initial 3-month estimate and it ended up being pretty close. Honestly, the 2 people that went through with us first were so patient and deserve so much credit because we really were not organized. We didn't have our stuff together. This was before Ashley Johnson took over. You know, we were trying to do this by the seat of our pants. And so it was really helpful to have a couple of our first learners who were patient and really contributed a lot and ended up being really kind of stars for us. So the really interesting thing is since then we've run several cohorts up to, I think we've run 3 cohorts now. There's an 80% success rate at completing up to the sort of dotted line of having sort of completion of the data science program. And then the big goal for us was trying to get people into jobs, getting people into data science jobs. And so, you know, if I had done this the smart way, we would have first thought about what are the potential barriers at the job stage and then worked our way backward. We didn't do that. We sort of live put people through the program and then realized sort of towards the end that there were some critical sort of issues with getting people jobs using this sort of alternative data science training pathway. So if anybody's ever looked at sort of job ads for data scientists, you'll see that the reality behind most of these data science jobs is what they really need is somebody to like automate their business practices and write some ad hoc database queries and things like that. But what they ask for, their sort of required experience is 15 years of deep learning in Python, a PhD thesis, you know, natural language processing in 7 different languages, and 10 years of creating Hadoop clusters from scratch. So kind of ridiculous over the top qualifications, even if they need something relatively simple done for their job. And so this is a big barrier, right? Because we have young people who we've trained and can do the basics, but that are, you know, not qualified in the usual way in the sense that they don't have like Harvard diplomas. And so how do we get them into these sorts of jobs? I feel like we were this close. We were so close to getting people into their jobs, but we kind of had run into this hurdle at the very last stage. And so what I ended up doing actually was, and I don't recommend this, but this is what we ended up doing to sort of solve this problem at the time. I reached out to a good friend of mine, Jamie McGovern. He was a friend of my wife. He was my wife's best friend's husband. He was kind of an incredible consultant and business person, and I asked him to start a company with me. And so we started this company that does data engineering and science as a service to give people basically their first job in industry. And so this company contracted with companies all around the country to do their, you know, data analysis and their data engineering, and all of the entry-level employees for this company were hired out of our training program. And so we headquartered that program. This matters a little bit less now because obviously everybody's at home and not going into the office. But we sort of put the headquarters of the company like right in the neighborhood where we did the training, right in the neighborhood where the scholars lived, with the idea that we could kind of generate economic opportunities right in the same neighborhood. So we basically developed this program sort of from basics all the way up to sort of connections. And so the idea here is that, you know, we would teach people to know about data science by going out and working directly with nonprofits, making presentations about data science, talking to the community. We would provide income security by paying people to complete the courses. We would give them an inexpensive computer that they could complete the program with. We created a program specifically and uniquely for individuals that come from this background and from this community to be able to be successful. We gave them access to instruction in a sort of asynchronous way, as well as a couple of synchronous hours a week. And then our initial sort of steps were to sort of solve the problem of the jobs issue by creating this company. And while that's sort of going on and it's ongoing, and we're actually talking to investors right now about sort of scaling that company up, We also have had more success talking to bigger businesses and starting to really work on how do we actually create economic opportunities at the big tentpole organizations in order for the people from our program to be able to graduate and appear, and be competitive for those sorts of jobs. So one thing I think I'm most proud of, and the credit here really goes to Ashley Johnson, our program manager, for shepherding this through our HR processes. When we originally tried to hire people from our training program at Johns Hopkins, including myself, when I tried to hire people from the training program into my own research group, there was no job code that could be applied to people that had the kind of background of people that we were training in this program. Anybody in a technical role would have either a couple of years of required experience or a bachelor's degree required. It would really sort of set a bar that made it impossible for people to sort of get into their first job. And so we worked with the human resources at Johns Hopkins, and we actually created a job code that was very specific for our training program. And I'm actually very pleased to say that just today, we actually had our first hire at Johns Hopkins of a person that finishes our program, and then they got hired at Hopkins through this new job code so that they could sort of start their new job. I've actually linked to here at the bottom to the description of that job. So if you're thinking of doing something like this, we actually have the job code so that you can carry that over to your institution and take it to your HR department and sort of work with them to sort of create these economic opportunities, at your host institution as well. So this has been really exciting. This is from an article that was written in the Johns Hopkins School of Public Health magazine about our program, and it's been really incredible to see the people that go through this program, to see what they've accomplished, to see how they've moved up in their careers. We've had people go to Problem Forward and then move on to a second job opportunity. We've had people who have now been hired at Hopkins. So it's really exciting to see this sort of growth of the individuals that come through this program. So as I sort of mentioned from the beginning, it's really not about the talent not being distributed, it's about the opportunity not being distributed. So again, talent is equally distributed, and these are a couple of the really talented people. If you ever run into any of them, you should hire them as quickly as possible. But opportunity isn't, and we're trying to make our very slight dent in that in Baltimore with our program by sort of creating these economic opportunities, both in terms of training and also in terms of sort of employment opportunities with Problem Forward, working with other companies in the community. And so this poverty in this community is pervasive, and I think that having programs like this and having access to them is a way to sort of grow an economic base for a community in the tech industry, which is a high growth industry that could create a lot of opportunity, not just for the young people that go through our program, but for all the associated people in their family who can take advantage of this sort of training and this sort of income as well. So as you've probably heard and thought about throughout this entire talk, there's been many things that you probably thought, oh, I definitely knew that before I said, we had done the wrong thing or done the silly thing. This whole sort of program has been an exercise for us in really learning and trying to gain knowledge about how do we execute this in a way that is both sort of thoughtful and sort of provides opportunities for people in a scalable way. And so we're still sort of working on that, and we're starting to think about our next iteration. Obviously with the pandemic and it's more difficult, we can't do sort of the in-person education we did before. We've also had a lot of outreaches from other communities to sort of try to launch this program in New York, in San Diego, in Tampa. And so we're starting to think about how do we scale the sort of CBDS plus component of the program. The massive online open courses are already scalable, but how do we scale the sort of more human touch part of it? And so the things that we learned from the pilot is that, training talented young people to do data science is a way to create a powerhouse, homegrown technical workforce that can really revitalize communities, but can also really provide economic opportunity for the tentpole organizations in a community. One thing that we've really learned and we're focusing on a lot for our next phase of this journey is that it's about mutually intensive learning. So not only do we have to train young people in data science and how to handle their first technical career, we also have to train the companies and the hiring managers about what is a talented tech person with talented technical skills but non-traditional qualifications look like. How do you support them? How do you mentor them? How do you make sure that they're successful? So we've been developing training materials and training programs that actually focus on the other side, on the hiring managers, on the data science managers, to try to help support the growth of people that come out of training programs like ours. And so the three most important pieces for this to work, so that we've learned from the pilot, are: one, hiring partners with the right knowledge, attitude, and resources. I would do that first above anything else if we had to do this over again. We really need nonprofits who can support the whole person. We work with people who have a lot of stuff going on in their lives, and we really need that infrastructure to make sure that they can be sort of successful in the program. If you kind of have distractions and big things happening in your life that you can't manage, it's going to really reflect in your success in a technical training program like this. And really the importance of mutual learning, both the instructors and the sort of mentors learning from the young people that are going through the program and trying to help support them, and the young people sort of learning about data science and learning about how to sort of take those first steps into a technical career. So our next phase is something we're calling Data Trail. And so the idea is this is all going to be online. It's going to be one big Slack channel. We're going to open it up, not just to Baltimore, it's also going to be opened up to other communities. And so we're starting to form those partnerships now. And it's going to have two kind of trails that come together. And so there's going to be data science learners that come in and get data science training, the financial support like we've talked about, social support. So we're working with nonprofit partners to create social supports that you can access directly through this Slack channel. And then on the other side, we're going to bring in data science experts and mentors and hiring managers, and we're going to give them sort of the training that they need in anti-racism and mentorship and HR best practices so that they can be ready to really support individuals that come out of our program, with the idea that ultimately we really want to be able to create diverse teams in technology that really tap into a really huge pool of talent that we've been neglecting over a long period of time. And we think that this can be like a small contribution to making that be more successful going forward. And so this data trail is a partnership of for-profit companies that are going to be hiring partners and mentors, colleges and universities that are going to help lead the training program, and nonprofit community partners that really provide that social support that kind of wraps around and make sure that the whole person is supported. If you're interested in this, if you're interested in the program, if you're interested in running it, clouddatascience.org/foreducators is a website. We have a whole starter kit for how you can run the program in your community. We also have instructor resources, a whole book of instructor resources for how do you teach with our materials. And so we're really working on developing this out and starting to think about train the trainer and really expanding the scope of what we've been working on. And so with that, I'll just say thank you very much for your attention, and I really appreciate the opportunity to tell you a little bit about the great work that a whole bunch of people have done in the Johns Hopkins Data Science Lab. Thank you.
Sarita, it looks like there's only one question.
Yes, we have a question here. So
how do we want to do this?
Yeah, I can just go ahead and share the question, and I think some other questions are coming in right now.
Oh, okay.
So the first question here is, do you think other schools will implement similar programs in the future?
The ones I know about are, so I know that there's a program about to launch at Mount Sinai in New York. Columbia has reached out about doing it, as is Moffitt Cancer Center in Tampa. We have some conversations with UCSD kind of in the early stages of conversation, but I do think that it's going to start happening in other parts of the country as well. At least it seems like it is going to. So that's obviously really exciting for us.
Sorry, trying to unmute myself. Thank you.
No problem.
So another question, some questions are coming in now quickly, pardon me.
Okay, great.
Is there something to be said for a project focused on getting traditional employers to accept alternative methods of education like this?
Yeah, so that's one of the big parts of this new data trail program that we're putting together right now, is basically building educational materials for employers so that they can take those trainings and like basically try to work on their own internal hiring processes. I'll tell you that it was like a more than year-long journey to create that HR job code change that we created at Johns Hopkins HR. It took us a year to get it through the system. And so I think it's going to be a matter of really, making sort of big inroads and efforts with not just the HR staff, but the data science hiring staff. It takes a while to make those things happen. So yeah, I think that part of the education is the part that we didn't realize we needed as much as we did. Again, I feel like everything I say is like, oh, we should have obviously known that was going to be a problem, but we just kept messing up. But we know that that's a problem now, and so we're trying to address it going forward.
Our next question is, are these kinds of programs relatively new or have they been around for a while?
There have been a couple of other programs that are really inspirational for us. I think this is the first one in data science that I'm aware of. I could be wrong. I'm not going to like say that we're the only people thinking about this, but there's been like a few great programs that are like this. Like Year Up does a really good job of this. InPower does a really good job of this. There's like a variety of different sort of nonprofits that do this kind of technical training. A lot of them focus in IT, which is sort of where another sort of technical area with big job growth. So that's been a big growth area. I think we're the first ones to do something in like R and data science. But this idea has, one of the things that actually inspired me was there was a program that actually did 2 randomized controlled trials where they actually randomized people when they could enter the program or not. And in both showed really massive increases in economic security and health and well-being after taking a program like this in IT. And with social interventions, that almost never works, that you get like replicating clinical randomized controlled trials that both show a massive positive effect. And so I was reading those and I was sort of blown away that this kind of educational intervention can have this really consistent big effect. And so that's one of the inspirations. So we're definitely standing on the shoulders of giants here in terms of the structure and the idea.
Next question is asking, what inspired you to become involved in these underserved communities?
Well, I mean, there's a lot of reasons. There's sort of personal reasons, and then there's also like, it's sort of hard to like work in a place like Johns Hopkins, which is such a wealthy sort of institution, and to like be plunked down in a community where there really isn't as much economic opportunity, and to just see that contrast every day. It's sort of impossible not to at some point feel like you have to do something, or you feel like you're really sort of, I don't know, it just didn't feel right. And so that's sort of the real reason that we got involved. And then since then, it's been nothing but sort of endorphin rush every time somebody like does well in the program. And so now it's like, I'm kind of addicted a bit. So yeah.
Have you considered randomized selection of candidates into training and control groups selection, and the zeal of the program managers may increase chances of success for accepted candidates?
Yeah, so we have really thought about that. Our pilot has been small enough so far that like randomization probably wouldn't tell you too terribly much. We were mostly just trying to make the thing work. But now as we're scaling up to larger cohorts, we just don't have enough money to enroll everybody in that. So we pay, at the end of the day, we end up paying about $2,500 to each candidate as they complete the courses, in addition to the laptop. And so there's only so many people we can afford to bring into the program. And so the way that these other programs have done these trials, and how we'll probably do it too, is we'll have randomized admission times. So we can only accept 10 at this time. So however many people apply, we'll take the 10, we'll at random take 10 people and compare their outcomes to the people that didn't get in this round, like over the next 6 months and over the next year. So we'll probably start doing things like that, but probably not until this like scale up to other institutions starts. These are great questions, by the way.
Do you believe that limited funding presents an impediment to scaling these programs? Would opening federal aid programs like the Pell Grant to more non-traditional education programs like this help?
So I'm of two minds about this. One is, as a person who runs a program like this, I would always love more funding. It's sort of, you're always trying to get funding together to do these sorts of things. On the other hand, I don't see this as a replacement for traditional education. I see this as a pre-step before you go get. So a lot of the people that take our program end up doing our program, getting their first job, realizing they could probably advance a lot further if they had a bachelor's degree or above. So then they use that first job to sort of start going back to college and getting more education so that then they could really move up. So I sort of see it as a multi-step process. And I'm a little hesitant because one thing we've learned about this is while there are a lot of good actors in this area, there's also a lot of, I would call it not like predatory, but definitely people who are out for that Pell Grant money. And so I'm a little nervous about unregulated programs like ours. We're not a regulated program. I don't think we should be getting Pell Grant money until we have some kind of regulation that manages what are the outcomes and make sure that we're not like taking people's money. We're in a good situation where we're not taking any money from people, we're giving it all away. But you can imagine if you open the doors to that, it could get a little dicey. So I'm sort of still of the mind that we should kind of keep that in regulated programs at the moment. But we've had really good success with, like, funders are really excited about, when they see this kind of success and they see the young people and they see how talented they are. It's been relatively, I mean, it's never easy, but it's been relatively easy for us to get funding, at least on the small scales that we're looking for to put people through the program.
The next question is, can you share more about the study that you mentioned, like a citation and author, the randomized controlled trial that showed the benefit of this sort of program? And then also just the question of your background.
Yeah, so I'm just trying to figure out, it's not Empower. Oh man, I can't now. The name of the trial is escaping me. I will add that to the slides. I don't have it off the top of my head, but I'll add it to the slides, and then when Carol posts it, there'll be a link to that trial in the slides. So sorry, I don't have that off the top of my head.
Thank you. How do you understand the mismatch between roles and responsibilities and required experience? Do businesses not know what they need, or is there an excess of overqualified people, or is there something else going on?
I think there's a combination of factors. One is it's a really technical field, and as a person who's both been an employer and a trainer of data scientists, and I've worked with other companies that are trying to hire data scientists, I can tell you that the definition of data scientist is like wildly different across industries, across companies, and so forth. And so some of it is people just have no idea what a data scientist is when they hire their first one. And so they just put every qualification they can think of in the hope that they'll find like the perfect person that knows everything when they hire that first person. So I think there's a little bit of that going on. I also do think that there's a little bit like in molecular biology, you see this, that there's something called a lab tech, and they're the person that just kind of like runs the experiments and does the pipetting and kind of manages the lab and stuff. And then there's grad students and postdocs and senior people. There's sort of like a gradation of jobs you can get. In data science, there really isn't yet. It's like you can be a data scientist, which is like a super high paying job only for PhDs from MIT, or you can be not in the industry. And that's a sort of ridiculous sort of state of affairs. There should be a whole range of jobs coming from like entry-level data scientists all the way up to like, super fancy pants AI developer for, Google. And so I think we just haven't filled in the entry-level stage of data science yet. And so I think that's going to happen. It's already happening at certain places. Like Google is doing this, and IBM is doing this, and Bloomberg is doing this a little bit, where they're like developing these first-level, entry-level jobs, but it's not common practice yet. So I think we're a little out ahead of the hiring practices here. So that's why we got to do the education part to sort of say, maybe you don't need to hire somebody with a PhD and 15 years of experience if what you really want is like your Excel files managed and a couple of plots made for your annual report. Like you probably could afford to have an entry-level person come in and do that really well,
A bit of a follow-up to that is, does Problem Forward work with businesses to create new types of roles, or do people graduate from the course into existing types of roles?
Yeah, so Problem Forward is a separate for-profit company from the training program, and that company hires people from the training program to be entry-level data scientists, and they do a job where they basically clean data and do basic analyses for big companies around the country. And so it's kind of a consulting / tech company that hires people to work on other people's data. And the real idea behind Problem Forward is that we can solve a lot of these problems that are really expensive for big companies because they're hiring $250,000 a year AI experts to manage their Excel files. Then we can do it for a lot cheaper if we hire people at like a more manageable salary to do that sort of thing. And then we hope that they'll do their job for us for a little while and then either go back to college or go on to another bigger job and make more money down the line. And so our real goal for Problem Forward is they come and work for us for a little while and then they move on and up, or they move up within Problem Forward to a higher level role. But so far we've had pretty good success at people like working with other people and then moving on to bigger, better jobs. So that's exciting.
A couple questions about females in the program. So what is your percentage of females in the program? And then just with the note that STEM programs have been historically male with low female participation, do you have plans to promote the program to women?
Yeah, so we try very hard to be sort of balanced about that. I would say we have a relatively small sample size, so we've only had a few people go through the program. We have had 2 people that identified not with either gender. We had a couple of women, and then we've had having 8 or so men. And so I would say we definitely are not balanced as well as we'd like to be, but is something that we're actively sort of working on. And so I think part of that is the selection process. And one of the things we're really sort of actively trying to do with this new data trail opportunity that we're doing online is, rather than having a rigorous selection process where so the way we've been doing selection so far is we do interviews, they give test scores, we do all the traditional sort of ways that you get into a program. And I think some of those things are sort of causing pipeline problems for us in terms of recruitment. And so what we're going to do instead is, there's a whole series of like really small level data science exercises people do along the way. And as they show excitement and interest, then we funnel them into the more sort of intensive program. And we think by making a more open recruitment process, we have a better chance of being more representative in who we brought in. But that's a hypothesis. I feel like I wouldn't say we're like clever or we know the answer to this. We're just trying our best. And so this is our new attempt at doing that better.
I think that's just about all the questions that have come in, so it's kind of great timing. A couple people have asked about the presentation being available, and
Okay, yeah.
posted, so.
Okay, as soon, you want me to take over? First, let me thank Jeff, because I had heard parts of this talk before at JSM, and that's when, at the joint statistical meetings, and that's when I asked the committee that I'm chairing if they thought this would be a neat talk, and they did. So I think it really was. I think it was awesome. And as soon as Sarita, and give her time, gets a chance to take the recording, or does the recording with you, Jeff? Who's got the recording now?
It will be with me.
Okay, so she'll clean it up, and as soon as she cleans it up, she'll link, you'll put it somewhere and link, and as soon as I get a link, eventually it will end up on the Washington Statistical Society Statistics Education Seminar YouTube. We have a separate YouTube channel for Washington Statistical Society, and one subset is statistics education. But it may be a while. You just have to be patient with that. And as soon as I get the slides from Jeff, and they can get posted somewhere. If you can post them, if you give me a link, Jeff, that's the quickest way. But I may have to wait a few days while they get posted on the WSS website if we decide to go that way. So I just want to say thank you, and everybody, I'm really impressed, because this is only the second talk we've done web thing, but one thing I noticed, because they gave me a co-host, is that nobody left. Once you came to the talk, everyone stayed. And I'm not used to that on these things. It's just totally amazing to me. Jeff, or Sarita, anything more to say?
I just wanted to thank you so much. We appreciate it. This was great.
Yeah, thank you very much for managing everything, Sarita, and thank you, Carol, for organizing, and thanks for all the great questions. It was really fun to talk to you all, and hopefully we can talk more soon. Thanks, everybody.